I need you to do an experiment. Come over here. I want you to put your hand down on this and see if anything happens. Can you give that a try? Yeah, you can go ahead and try all three of them. Does it make a difference? Are you seeing anything going on? What do you think that's making that change? Is it pushing? Can I do it if I do it really light? I want to actually tell you that this has got something to do with temperature. And maybe the best way to show that is I have a heating pad here. So I have some warm little samples. If we stick that under, can you tell me what's in the little envelope? Oh, okay, that one's got an E inside of it. Let's try another one. That one has a T. So what we're studying here are different kinds of sensors. How do we detect the presence of something without being able to see inside? And this is something that detects temperature. These are called liquid crystals. Oh, that one's a heart. That's nice. These are liquid crystals. Have you ever heard of solids and liquids and gases? I bet you have. Well, liquid crystals are something kind of like that. In a solid, the molecules all line up in a regular pattern. In a liquid, the molecules don't line it up at all. They're just sloshing around. A liquid crystal is somewhere between a solid and a liquid. There's short range order, but there's not long range order. And when we change the temperature, those molecules change position, and we get a color change. Let's try one more here. Oh, okay, that's an H. Since you asked how come there are different colors, I need to tell you a little more about the structure of the molecule. Some kinds of liquid crystals, you have a molecule, the next molecule is oriented a little bit differently, and you end up rotating around in a spiral. So in my molecule models here, each popsicle stick represents a layer of molecules. And from one molecule to the next, they're rotated a little bit. In this one, there's a rather big step, which means you get around quickly. In this model, you have a rather small step, so you get around more slowly. Light shining on these two different arrangements would end up being different colors. As the molecules expand and contract away from each other with temperature, we get a different color of the material. Now, can you guess which one of these is the warmer material? Right, it's this one, because when we warm up the liquid crystals, the molecules get farther apart. A fun application of liquid crystals is mood ring. As your skin changes temperature, then the mood ring changes. A more serious application is a liquid crystal thermometer. In a liquid crystal thermometer, for each temperature, you have a different composition liquid crystal, and as it reaches the liquid crystal phase, then you see that color temperature light up.